I'm continuing with the file from the last video, but you can also find it in the description below this video. So let's say we have something deeper than this water tank here. For example, something like this. You can use a narrow band of particles only at the water surface because the surface volume will take care of the inside. Inside of the dot network, on the flip object, there is an option in the initial data tab to use a narrow band. It's going to need a narrow band of particles and a volume, and the velocity volume is optional. I'm not going to be using it. So I'm going to go upstairs, and instead of using the points from volume, I'm going to use an ocean source node. And it's going to error because it's expecting some inputs. So in surface evaluation, you can change the type to flat, and then it's not going to expect anything. So I'm going to remove these and this one and cut this and replace it by this one. Then I'm going to set its size, and I want its size to match whatever the bounding box is. So I'm just going to use the bbox and centroid expression again. So bbox, and then outside of this node, I want this node here, bounding box, and then I want the size of x. So d underscore x size. And I'm just going to copy this parameter and paste it into here, and the size of y, and finally the size of z. I want to do the same for the center, so centroid. And out of this node into bounding box. Then I want the center of x. Copy this and paste it here, change it to center of y, and finally center of z. So we're going to match whatever is inside of here. And for the particle separation, I want to match whatever is inside the simulation. So I'm just going to grab this parameter. So I'm going to right click, copy parameter, and then in here I'm going to right click and paste a relative reference. And then in case I change the grid scale, which I'm not planning on, I'm just going to copy the grid scale as well. Copy parameter, and in here paste relative reference. So we got both of these. I want to fill the volume, and if you fill the volume, you get this option to use a narrow band of particles. Right now it's set to be 1 meter thick. I would like it to be thinner, but I'm going to fix it a little bit later. On the flip solver, you have the option to use a narrow band. So if you toggle enable particle narrow band, the solver is going to expect it. And then it's asking for the bandwidth, and that's the width of the particle band in voxels. So right now it's 3 voxels, which is good. But I want the layer size of the ocean source to match this. So to figure out how much this is in meters, I can say 2 times the particle separation is 1 voxel. So you can say 2 times 0.03. So this is 1 voxel. And then I want 3 of these, so times 3. But we should actually make some relative reference. So I'm just going to copy the particle separation and paste it in here, paste relative reference. Then I want to copy the grid scale, copy, and then I'm going to multiply it times paste a relative reference. And then I'm going to go into the dot network and grab the bandwidth from the flip solver, copy parameter, and in here I'm going to multiply it by that as well. Paste relative reference, and again we have the layer size of 0.18 or 18 centimeters. If you check the info card of this node, you'll see you got some particles, and then you got 1 volume surface. I'm going to isolate the particles and isolate the surface. So up here I'm going to put down a blast node, and all of these particles are in a particle group here. So I'm just going to say group type to points, and if you are in the group particles, then delete non-selected. So now we only have the particles. I'm going to connect this to my old null here. We can call this particles. Then I also want to isolate the surface, and the surface is kept inside of a primitive, so I can just say blast again. and is the first output of the ocean source. And in here, I'm gonna say it's primitives, and if the attribute name is equal to surface, then delete non-selected. So now we only have the surface. I'm gonna create a new null for this and call it surface. Then inside of the dot network, I'm gonna go back to my flip object, and the subpath is already pointing at the particles from before. And then I'm gonna pick up the volume, so I'm gonna go out of this node, up one level, and then I called it surface, this one. So that is this node here. And now you can see there are only particles close to the surface, but we do have a surface volume that goes all the way down. Let's play it. I'm just gonna stop it here, and then I'm gonna hide the box. And you can see how the particles are only created at the surface of the water. And this allows us to get some nice splash detail out here with not too many particles and maintain the volume of the water at the same time. I just realized I didn't hook up the division size in here, so I'm just going to do that real quick. So upstairs, I'm just going to grab this voxel size from the collider and go back inside and paste it into division size. Paste relative reference. And if we reset the simulation, we can export this the same way we did before. So down here, I can put down a DOP import fields. I want to import 3 things. And the node I want to grab is this one, so .NET 1. And then for the DOP node, I want the flip object in here. So I'm just going to go out of this node into .NET 1, and then it's called flip object, which is this one, like this. And now we got the particles because the fields are empty, but I'm going to choose the flip object in here, and then I'm going to choose the particles, which is geometry. There is this one, and then I want the surface and the velocity. So again, flip object, surface, I'm going to make it invisible, and flip object again, it's called well, and I'm going to make it invisible again. The reason you have the smoke above the water but not inside of it is because the surface field has positive values outside the body of water, and then on the surface of the water it has the value of 0, and inside the body of water it has negative values, and the more negative the deeper it goes into the water. That's why it looks like this. I'm just going to take it back to invisible. And it's the same with the velocities. This is actually showing 3 fields, and when the velocities are in negative x, for example, they're going to be invisible, but if they are in positive x, there's going to be some smoke. Then I'm going to compress this, so fluid compress, make it a little bit smaller on disk. I'm just going to grab the particle separation from, I guess I can just take it from here, copy parameter, paste relative reference, 0.03, and then I'm going to put down raw geometry output. I'm going to call it simulation. And then I'm going to add the folder in here. So I'm just going to grab these 2, copy them, and do /paste. So make a folder with the name of the HIF file and the name of the node. I want the full frame range. I'm going to save the scene and save the disk. And now I'm going to read it back in. So I'm going to put down a file node. So inside of Geo, we got water version 2 simulation. And then I'm going to use particle fluid surface to turn this into a polygon soup. This one. And I want the particle separation to match the separation of my simulations. So I'm just going to go up here to the ocean source and grab the particle separation again. So copy parameter and paste it into the particle fluid surface. history to reference. And we got the surface. I'm going to use the bounding box to cut the box. So inside of regions, I'm going to toggle use bounding box, but first I'm just going to go into manual and I'm going to say use bounding box, and I'm again going to use the bbox expression and the centroid to get the bounding box from up here. That way you can just change this bounding box and that will change everything. So I'm going to say bbox out of this node, and then it's called bounding box. And then I want the size of x, so dx size. Copy this and paste it. I want y. And then set. And so now we should have 5 times 5 times 5, yeah. And then I want the centroid. So I'm going to do the same, but the centroid. Out of this node, and then null is called bounding box. And then I want dx, the center of x. Copy this, the center of y, and the center of z. Just in case I move this box somewhere away from 0, 0, 0. So I guess we can go back into auto update, and if we want, we can close the boundaries, something like this. If you go back to surfacing, you can set the influence scale. So this is how tightly around the particles the surface should be created. So if you take this down, let's take it down to 2.5. You can see the surface moves closer to the particles. Take it back to 3. Goes a bit further out, or at least it should go a little bit further out. Then the droplet scale is the same. It has to do with particles that don't have many neighbors or droplets like these ones. So if we take this down, let's try 0.5, then it goes inwards. Just be careful with these values. If you take them too low, you're going to get weird holes and artifacts in your water surface. A good rule of thumb is to make the droplet scale 1/3 of the influence scale. So we can copy these parameters and paste it in here, and then divide it by 3. So if we want to take the influence scale a bit up or down, the droplet scale will follow. And now I'm just gonna adjust the camera a little bit. And I want to object merge my box. I guess I'll just take the collide geo. So out of this node, collide geo, merge the two together, and I'm gonna make a final flipbook. Gonna right click, and in size, yep, they're already off, so that's good. It might have been worth it to write out the surface first before doing the flipbook, but I did not do that. So it's a pretty low-res simulation, but I'm going to stop here. Thank you for watching. I hope you learned something from this video and the ones before, and I hope you have a great rest of your day. Thanks.